Right, hello. So my name is Michael Pellick, and my group did our B1500 project on hockey teams and hockey data for the course of like over 100 years. We got data from hockey teams, and we basically wrote a code to sort through that data. So without further ado, let's jump over to MATLAB. All right, so in MATLAB, our main script is the menu script, of course, and this is the main control of the functions. So basically, after the data is imported as column vectors, the script prompts users to enter a series of menus to choose a league and then a team. If they, for instance, select NHL, the script asks for a conference and divisions before displaying the choice of teams. Once the team is selected, the menu script uses the variables from the menus to send it through the data finder function, which we'll get into later. And basically, the script then gives the user the choice for the different questions it can ask. It calls the function, then gives the option of running another question, another function. If no is selected, it presents the option of selecting another team. If no is chosen again, it ends the program, and that's the function. So basically, we use a while loop and then if statements for like the leagues we have. If it's like NHL, sometimes some leagues we have like the NHP or WFL. Basically, it runs through that, and basically the user can choose a team, and then once the user chooses a team, it can pick a question, which that question is related to each function, which we'll get into. So basically, yeah, that's basically it. It selects the team, basically selects the team, and then once we get over here, we have please choose a question, and we use if statements. And whatever choice they select questions, that's what the function is called on, whatever question they chose. And that's pretty much the menu function. So if we get into this, if we run this for instance, and for instance, let's select NHL. Let's do a Western Conference and Pacific. And let's select the team. Let's do the Edmonton Oilers. So basically, once we select a team, we're prompted with 4 questions we can ask, and these questions relate to functions. So we're going to minimize this, and we're going to move on to our data finder function. So basically, this function uses the variables assigned in the menu script to determine the team that should be analyzed. After evaluating several if statements, the team is set to its team ID. The function uses find to determine which row of the various data columns correspond to that team. We were able to use a loop to streamline this because some teams have the same name but in different leagues or change names. Once the locations are found, the function pulls the corresponding information from the year, ranking, wins, and losses. So basically, these if statements, like if league equals 1, if team equals 1, relates to basically what we had in the menu before. And basically, for instance, we find the team and we set variable, so we find the team ID, and then we find the years in our data that team appears in, and then the rankings for that team, and then we find the wins losses. And basically, this is where we get all our information for the other functions, where the functions communicate with each other. So this is basically all the teams. There's over like 100 teams, so this is all our code for the teams that we have in our data set. So moving on to the ranking function. So this function takes the year and ranking outputs of the data finder function as inputs. And firstly, it measures the length of the team vector, which is over here. Then we initialize r squared. We initialize r squared. Then we run a for loop for the degrees to determine which polyfit we'll use for the degrees. And then we use an if statement to determine the best fit with an r squared value. Then the function uses a for loop to plot the rank, with ranks 1 to 3 being colored, which is right here. The team had rank 1. We used a blue star, then rank 2, red star, then rank 3, green star, and then everything else we just used black O's. And then it basically plots the best fit line and displays the R squared value. If the team was not active for multiple years, the function just plots the color point for that year. Because some teams only were in the league for like 1 year, so it's not gonna display like a perfect graph for that team. So if you go back to our questions, and this is ranking, so ask what was the ranking year to year. We select that, and basically we get this best fit line in Polyfair. So we have rankings 1, 2, 3, then all the other rankings, and then we use curve fitting to basically graph it. So let's hit the question. Yes. Let's minimize this, and move on to comp rivalries. So basically, this function takes the original 6 hockey teams and shows their rivalries in the input, this section of the function. And basically, the original 6 NHL teams, there are rivalries between them, and basically for each team, we found the team in our data set with a team ID. Then we found the wins and losses. We did this for all 6 teams. And then we decide the visual representation for this function would be a bar graph. So basically, we made a matrix of each team, and then we made a matrix for basically the sum of their team's wins. And then this displays in the bar graph, and we had our legend, X label, Y label, and title for it. And basically then we printed out like which teams had more wins. So basically, this says if the Bruins had more wins than the Canadiens, then it displays the Bruins had more wins than the Canadiens. But if they didn't, then we ran an else if statement to say that the Canadiens had more wins than the Bruins, and then we ended that. And basically, we did that for wins, losses for each rivalry. So for each rivalry, we did that. We ran through that, and basically, we got a bar graph. So if we go back over here, and we go to how did the rivalries match over the years? We hit that. And then hiding, and then we basically get this display saying that the Canadiens had more wins than the Bruins had more losses than the Canadiens, that sort of stuff. So that's that function. Then moving on to hockey playoffs. Basically, this function, we look at how the teams did in the Stanley Cup playoffs, or the hockey playoffs in general. So basically, we find the team that the team selected. Now all these if statements relate back to the data finder one. So basically, if they selected this, we find this team ID, and we basically find the team IDs for all NHL teams. And once we find all the team IDs, we then take the length. And basically, all those teams IDs are stored in the variable find hockey team. And once the user selects what team they want from the menu, this is already selected. So then we take the length of find hockey teams. Then we initialize the playoff results. There's 23 playoff results that we initialize for our table. Then, since the vector we have is categorical, we convert it into a string since we're more familiar with working with strings. And then we use a for loop, and this for loop runs from 1 to the length of the team vector we did. And we basically switch off the different playoff cases. So there's 23 playoff cases, so there's 23 case statements of each playoff. In each playoff, we basically find what year they made it to that point in the playoffs, and we indent it with the year, and then we print out the playoff appearances, like SF or like Stanley Finals. We print that out, and there's 23 case statements. And then we have to determine the length of each playoff vector, because since we're displaying this in a table, each column has to have the same number of rows. So basically, we find the max length of each individual playoff case. And then we use an if statement to determine who has the largest playoff vector. So we can basically add zeros as placeholders as we see from the table. So we do this for each playoff case, 23 playoff cases. And then we display the final results as a table. So if you go back to MATLAB, we close the figure. And would you like to ask another question? Yes. What were the playoff results for each year? We hit that. And basically, we print out the playoff appearances. It's organized for like CQF, which is conference quarterfinals, and F, which is finals. And we display a table. We have the headings, which is the 23 playoff cases, and then we have the years associated below each column for that. Finally, moving on to our last function, which is the winning function. And basically, this function takes the years, wins, and losses outputs of the data finder function as inputs, and the function then creates a table of wins and losses for each year and displays it. The function then calculates and prints the the descriptive statistics of the data. This includes for both the wins and losses, the min, max, mean, and standard deviation. So basically, we get our, we set up the variables year, wins, losses. And since we want a table, we create a table of each headings, which is years, wins, and losses. And basically, we find the total number of wins and losses, whichever team user selected in the menu. We find those totals, wins and losses, and then we create a pie chart, which displays a pie chart. And then basically, we calculate the average, standard deviation, max, and min of the wins and losses from whatever team the user selected. And then we find the maxes using the function loc. So we locate the years of the maxes, the mins, and then we basically print out the results as you can see here. So if you go back to MATLAB, would you like to choose another question? Yes, and then we go back to total wins and losses. Basically what you see here is for the Edmonton Oilers, that's the team we selected, we get years, wins, losses, and each year displays the numbers of wins and losses. And then we get a pie chart to see overall how they did. So 53%, 47%. So 53% of the time the Edmonton Oilers won their games, 47% of the time they lost their games. And that is that function. So that is our project on hockey teams and hockey data for B1500. Thank you.